An accessories company finds that the cost and revenue in dollars of producing X belts is given by, we have a cost function there and we have a revenue function there. It says determine the rate at which the accessories company's average profit per belt is changing when 177 belts have been produced and sold. So there's a couple things to consider. First off, they're asking for profit, or specifically average profit. We have a cost and a revenue function. So we really should consider beginning this problem by finding the profit function. So we can use the definition for profit as revenue, which we have a function for, minus cost, which we have a function for. So we'll begin there. The profit function is our revenue function, 35x to the 9/10, minus our cost function, which is 3 terms. So you either got to put those 3 terms in parentheses behind that negative sign, or you can just apply the negative sign to all 3 terms, which I'm going to do that way. So we're going to be subtracting that 720, subtracting that 39x, and then we've already got a negative in that last term there, so that'll end up being a plus 0.068x squared. Now this is the profit function, and that's actually not what they're referring to in the question here. We want the average profit function. So if you consider what the profit function would give us as an output, if I were to, let's say, plug in 177 belts. The output here would be the total profit associated with all 177 belts produced and sold. So a per belt average, we would need to divide that total by 177. So when it comes to defining the average profit function, which they have notated here with the little hat above the P, or P bar, I guess you could call that, but this is just a way of notating the average profit function. We have to take the profit function and divide by X, divide by the input. Whatever the input is, we ultimately have to divide by it to get a per belt average. So currently we have this profit function defined as with 4 terms, and the easiest way to get this done, I would say, is to divide all 4 terms individually. You can divide all 4 terms like that by X, but then you end up with having to use a quotient rule, and it's a little bit more algebra than we would like to use. So alternatively, we can divide all 4 terms individually, and that will allow us to find the derivative a lot easier, because ultimately we need to find the derivative. When you see the word rate, it's not even asking for the average profit when 177 belts have been produced and sold. It's asking for the rate at which average profit is changing when 177 belts have been produced and sold. So after we find this average profit function, then we have to find its derivative, which means we really should consider how we set this up. So again, to find the average profit function, I'm dividing all 4 of these terms in the profit function by X. So this first term here will be 35. And when you're dividing like bases like this, so for example, 9/10 divided by X, you can simplify this by subtracting their exponents. So we have 9/10 of a factor of X up top, we got a full factor of X down below. To simplify this quotient, we can do 9/10 minus 1. Or 9/10 minus 10/10 is a way to think about that. Either way, you should get negative 1/10 as the new exponent. 720, if we divide that by X, we could write it like this, and that works. But you may recall from class this week, if our goal is to get the derivative, it might be more convenient to write this as X to the negative 1. If I divide the third term here by X, negative 39X, then the X's will cancel and it leaves behind just the minus 39. And then this last term, again, if I need to divide X squared by X, I can use that property of exponents that says if you divide like bases, subtract their exponents. So 2 minus 1 is just 1. So that last term there becomes 0.068x. So this here is the average profit function. And we need this, but this is not what they're referring to in that answer there. When it says find the rate at which average profit is changing when X belts have been produced, we need the derivative. So we'll go through here. We can now call this average profit with the prime symbol there, just a way to reference it's the derivative. We'll go term by term using the power rule. So this negative 1/10 is going to come down and multiply the 35 there. So we should have negative 3.5 because we're dividing by 10. Right? We're going to subtract 1 from the exponent, which if you think about, it's already negative, so it's going to be even more negative. Negative 1/10 minus 10/10 is negative 11/10. Here the negative 1 comes down, multiplies the 720. Reduce that exponent by 1, so now we're at negative 2. This third term here, here we go, is a constant. So when we take the derivative of a constant, it becomes nothing, so we won't add 0 here. We'll just omit that. And then this last term is linear, so the slope is just the coefficient out front. Or you could say, with the power rule, the 1 comes down, multiplies the 0.068, and then we have x to the 0, which just goes away as a factor of 1. So here's our derivative for the average profit function. We can refer to this as the rate at which average profit is changing when X belts have been produced. So this function here should be our answer for the first part of this question. Now there's different ways that you could write this average derivative average profit function here. This is fine. I mean, you could take care of these negative exponents, for example, if you wanted, but no reason why we can't enter it exactly like this. So I would put it in there. So this is the answer to the first part of this question. Now next up, they want us to evaluate for a specific number of belts, 177 belts. So we can do that easily enough with the calculator. Now let's see. We've got negative 3.5 in parentheses, or you know what? Here's not. You could in parentheses write your 177, but another convenient thing we could do is I could write 177 in the calculator, and I could press this STO button, which refers to store. It's right above the on, and then I can press the variable button X. And what that does is it stores the value 177 to X. And it just makes it a little bit more convenient now. So if I want to evaluate this function, I could just type the variable X, and the calculator is going to know that I'm referring to 177. That's just an option. So I'm going to type this function in. Let's see, plus 720 x to the negative 2 plus 0.068. Just double check to make sure we type that in right. It looks good. Now this should be our answer. And let's see. The question wants us to round to 4 decimal places. So we'll write this as 0.0792. And they also want the units associated with this value. So when you're talking about a derivative is a rate of change. So it should always be a relationship between two variables. We've got the output, which is dollars. We've got the input, which is number of belts. So it would be output per input. Think of it that way, or in this case, dollars per belt would be the units tied to our value here. So this would be the second part of this problem. And that's it. Hopefully you find that helpful. Thanks.